Hi, Dominic. Great to have you here.
Thanks for having me.
In an interview a couple of months ago, you said Dfinity, your platform, will make the internet complete by reinventing it. Why do you think it's time to reinvent the internet?
So Dfinity is a foundation, and it's developing something called the Internet Computer. And the Internet Computer extends the functionality of the Internet so that it can host new kind of Internet-native software. So people will be able to build websites, enterprise systems, and Internet services directly on the Internet itself. So to explain how it works, today the Internet is created by a protocol called IP, Internet Protocol. And IP combines thousands of private networks around the world to create a single global public virtual network, the Internet. And we often forget the Internet is created by a protocol that combines all these private networks. And it created this platform for creativity and economic growth because it was open and permissionless. The Internet is a very different thing to America Online or CompuServe, or back in the 1990s, Microsoft wanted to create something called the Information Superhighway. These are very different things. They're proprietary networks. The Internet is a public network. It's open and permissionless, and it's created by combining private networks. So the Internet Computer works in a similar way. There's a protocol called ICP, Internet Computer Protocol, and it combines compute capacity provided by independent data centers to create a seamless universe into which you can upload software, and it runs in a rather different way. It's unstoppable, it's secure, it provides support for something called open internet services. And we think it's an important step forward in the sense that the same kind of benefits that the Internet provided with respect to connectivity, the Internet Computer can provide with respect to computation.
Before we go deeper into that, I would like to understand, was there a moment or something that happened when you thought, okay, it's time to change something, it's time for this Internet Computer?
Well, I mean, I've been, for example, programming now for almost 40 years. So, I've got a lot of experience with technology, and I've seen how the ecosystem's developed over these last 4 decades, and I've seen...
And what is the problem of these developments?
Well, sometimes it's problems, and sometimes it's opportunity created by change. So, for example, in 1982, I got a computer called a personal computer, or got access to a personal computer called a ZX Spectrum. It was created by a British company called Sinclair Research. And this ZX Spectrum had been through a series of evolutions. I think it started with 16 kilobytes of RAM, then it had 64 kilobytes of RAM, and then finally in 1982 it got 128 kilobytes of RAM. And I remember marveling as a boy, how could this personal computer have 128 kilobytes of RAM? But last week I went into the Apple store in Palo Alto, and the new MacBook Pro can be configured with 60 gigabytes of RAM. 60 gigabytes of RAM. So in under 40 years, the amount of memory available on a personal computer has increased 500,000 times. 500,000 times. So, similarly, I remember upgrading from a 9600 baud modem to a 14.4K modem and thinking I was the boss. Yeah.
But then when you look into what happens in the internet, and obviously you were talking about big monopolies and so on, so then you decided something is going wrong and we have to do something different.
Sure. So the opportunity is the changed hardware landscape. Far more powerful computers at lower cost, far faster networks, and really a very dramatic change. An increase of 500,000 times over those 40 years with respect to memory, say. And this opportunity, this provides the foundations to create a different kind of platform that solve some of the emerging problems of today. So,
which is what?
Monopolization. So it's long been the case that technology companies have tried to establish monopolies because that's how you make the most money. And it was probably, we saw this early on, for example, with Microsoft. That used its control of the operating system to monopolize, for example, productivity applications. And the same pattern repeated on the internet, and Silicon Valley has always known that every startup should try and become a monopoly. And that's the primary aim. And with internet services, you do that by hijacking user data and getting far enough ahead that you get these compounding network effects that makes it impossible to compete with you. And we're seeing increasing monopolization. So, monopolization runs across everything from apartment rentals, Airbnb, through ride-sharing like Uber, auctions like eBay, right the way up to social networks and search. And the bigger monopolies are now buying the smaller monopolies, so you've got this increasing consolidation. And it's very, very bad for the end user, who increasingly loses power over their data and identity. It's also very bad for innovation. And this is the subtle side effect, but it should be no surprise that a system of monopolies doesn't produce the most creativity and innovation. And so we want to fix that. The problem really relates to something called platform risk. And an early famous example of platform risk in action occurred when Zynga, the social games company, built on top of Facebook. And they became the world's largest social games company, but a majority of their titles were published on Facebook. And it was okay for a while. They managed to go public, an IPO. They were worth about $15 billion at their peak. And then one day, Facebook changed the rules. The APIs that they built on changed from under them.
And then they lost 80% of their value within a couple
85% of their value in 3 months. More recently, an example I'm very familiar with personally, LinkedIn, the network of professional profiles, made APIs available that allowed startups to incorporate the professional profiles in their own services. And thousands of startups did this. But then one day, not so long ago, Microsoft bought LinkedIn, and they revoked everybody's APIs, with the exception of a few sort of fellow big tech players like Salesforce. And so all of these thousands of startups were wrecked. Some of them had to sell themselves to the big tech players so that their products would continue working. And that's an example of how this problem with monopolies is harming innovation and creativity. Sure. Because actually, there are thousands of business services that you might want to build on the internet that need access to the user's professional profiles.
Okay, and then now let's discuss how Dfinity will change that. So how will this new internet computer be different and completely open in the way that these problems don't occur anymore?
Well, so first of all, obviously, the internet computer can host websites and enterprise systems and internet services, but you're building on the internet. You're not building on big tech. So you're not building on Amazon Web Services or Google Cloud. You're building on the internet. So that's very different. The framework it provides for software is unique and has a number of features that are made possible by the architecture. So one of them is that it supports something called autonomous software. Autonomous software runs without an owner, and it makes it possible to create internet services that run as part of the fabric of the internet itself, rather than...
Which is not possible at the moment in the internet.
Well, I mean, it would have been possible. I mean, if you want, you couldn't build an autonomous internet service on Amazon, say, because you need a commercial relationship with Amazon. There needs to be a legal entity, right, that pays the dues. So the internet computer enables different models. The really important thing about open internet services built with autonomous software is that they can guarantee APIs in perpetuity. So you could use the internet computer to create an open version of LinkedIn. And the open version of LinkedIn would, of course, have an API that allows people building other services to pull professional profiles and incorporate them into the other service. Now, the difference is that if you go to a venture capitalist today and say, I want to build a new business service, look, it's a great idea, but I have to pull the professional profile from LinkedIn. Well, in actual fact, you can't do that anymore because LinkedIn's already revoked everyone's API access and closed it down. But assuming that LinkedIn still provided the API, the venture capitalist would say to you, well, look, that sounds like a great idea, but what happens if LinkedIn decides to turn your API off, right? The difference with the internet computer is somebody can build an open version of LinkedIn and create APIs that cannot be revoked, that can be guaranteed to exist in perpetuity.
Understood. Okay.
Yeah, and so now potentially thousands of new services can be built on top that extend the functionality of open LinkedIn.
And also you're building a new kind of cloud, and this cloud is not on one server of one company, it's on many different servers, right? How does that work?
So there aren't any servers involved. There are server hardware, the data centers run, but these machines run software that interacts with the ICP protocol. And of course, they run special software too. And the Internet Computer Protocol, together with the software that supports that protocol running on these machines at data centers, combines all of the compute capacity to create the internet computer.
So when I'm a company and I want to store my data in this new kind of cloud, you would put all my data on several data centers. Is that right?
We wouldn't. I mean, it's an open protocol. So the protocol manages the distribution of data and computation. There is no controller as such. There's actually the internet computer has an onboard governance system that performs some roles in the same way the internet has ICANN, for example, and IANA. But it's an open protocol and it self-manages.
But do I know where my data is? Is that GDPR compliant?
Well, that's a good question. I mean, does GDPR apply to the internet computer? So first of all, there's no direct analogy between something like Amazon Web Services and the internet computer. Amazon Web Services is a proprietary infrastructure that is owned and managed by a company. And, that's very different to the internet computer, where the data and the computation lives within the protocol. So, for example, it's more analogous to the internet itself. Data that is covered by GDPR is processed by the internet all the time. And that data is transferred through a series of devices like internet routers, where it in fact is stored for some time. But if GDPR applied to the internet protocol, people would have to switch off the internet, right? Because the internet transiently stores all of this data. So the internet computer isn't a proprietary infrastructure. The internet computer is a protocol. And the computer protocol is what determines where your data is stored or where copies of your data are stored, because it replicates data for reasons of sort of performance and redundancy and security and so on.
Any big companies that are interested in the technology already?
Yes, lots of companies. I mean, one of the key features of the Internet computer is that it hosts software that can be used to build websites, enterprise systems, internet services in an environment that's tamper-proof, where they run with the same guarantees as smart contracts.
Yeah.
So when you build a system on the Internet computer, it starts off secure. It's secure by default. And this is very important for a lot of companies because it's very difficult to make systems built with the legacy stack secure. It's a different model. Say, for example, you're building an enterprise IT system. Today, you'll choose a cloud provider, perhaps, or use a data center. You'll assemble a bunch of components like databases, web servers, middleware. And the system you build provides the functionality that you desire, but you must do additional work to harden it. So, for example, you will surround it by a firewall to protect it from the outside world. You will configure it very carefully to make it secure. Yeah. But, if there's a single mistake, if you make a bad configuration, if you forget to patch one of the software components like the database or the middleware or the application server, hackers can jump over the firewall. Yeah. And in fact, it's almost impossible to make IT systems secure today.
And you are from the UK. You work now in Silicon Valley in Zurich, but also you are from Europe. And there's this big discussion at the moment what the future role of Europe in the digitization innovation will be in future. So at the moment there's this big fight between the US and China. But what role will Europe play? And is there a USP, a tech USP that we could use maybe to play a bigger role in the next couple of years?
I think it's changing. The Internet Computer Project demonstrates what's possible. I moved from the UK to Silicon Valley, Palo Alto in 2012. But actually, the Dfinity Foundation is based in Zurich, and we have currently our largest research center in Zurich, so I'm always in Europe. The team we have there is absolutely beyond compare. Anybody that's interested should go and look at our website and check out the team page. I think it's fair to say we have the strongest team in the world.
But when we look into Europe, I'm sure the team is great, but so what would you recommend maybe the politicians in Europe what kind of policy would help the European tech scene to thrive?
A lot of it's to do with network effects. So, the more successful technology ventures we have in Europe, the more there will be. So in fact, one of the reasons that we've been very successful in Zurich is you've got three large organizations nearby. One is Zurich ETH, which is a fantastic university for cryptographers and distributed computing specialists. And we hire from there. And you've also got Google's European Research Center, so we hire a lot of people from there. And IBM's European Research Center, and we hire a lot of people from there. So it's because of these pre-existing...
But they're all not European companies.
Well, no, but we're hiring a lot of them. I mean, the majority of our employees are actually European. I think a lot of this is to do with access to capital and network effects. And the Internet Computer Project, because it's dared to be very ambitious and addresses very big, major problems afflicting the tech industry today, has been able to raise very large amounts of money, and that's enabled us to create a sort of big, fantastic team. So
how, in one sentence, how will the Internet Computer help the European tech system?
Well, first of all, it will create, once the Internet Computer's live, and we started pushing technology into the public domain last year. Once it's live, hopefully later this year, it'll create huge opportunities, new opportunities for entrepreneurs to reinvent existing internet services in open form. So people, could start with something very simple like LinkedIn. And actually, in Davos in a week, we're demonstrating the current internet computer network running from some Swiss data centers and a thing called Linked Up, which is a jokey open internet service, which obviously is an open version of LinkedIn. But you can do anything. I mean, look, why do you create an open version of Salesforce or an open version of WhatsApp or Instagram? The internet computer will make it possible to reinvent monopolistic proprietary internet services in open form, and will provide a platform that gives you unique features that will enable you to compete, namely that you can share your data and leverage mutualized network effects in a much more dynamic and collaborative ecosystem. So we believe, 10 years from now, we'll see a very different internet landscape, and entrepreneurs that are interested in building these open services can download, for example, this thing called the Motoko SDK and start playing around.
We are very much looking forward to see how that happens in the next 10 years. Thank you very much, Dominic Williams. Thank you very much for coming for the discussion.
Hey, thanks.